Hey there, welcome. And in this video, what we're going to be doing is actually continuing learning how to solve one-step equations. In this video, we're going to be exploring what to do if we see denominators or if we see on the next page reciprocals. You might remember in our previous video, what you guys learned how to do was actually just straight up identify the different parts of the expression. And then after that, you learned what to do if you saw a constant. So for example, in this problem right here, you should already know what to do with this and identify that we have a positive 6 as our constant. If we see this problem right here, for example, we should recognize that we have an 8 that is our constant. The number all by itself, the constant in this one would be a -3, and the constant in this one is a 5. The one right below it, we have a constant of 1. And so you guys learned how to identify constants, and then you learned what to do on this page when you see a constant for how to solve. So a quick refresher, if we saw a positive constant, then you want to subtract on both sides. And so 6.5 minus 5 would be 1.5 on this one. So for this one, we'd get m equals 1.5. And if you see a negative constant, you just do the opposite, which is to add. So we've already covered what to do if you see constants. And if it's positive, you subtract, and if it's negative, you add. And here we'd get a -7. So y equals -7. All right, now what we're doing in this video, though, is what happens if we see denominators. And then again, on the next page, we'll talk about what to see if we see fractions involved. So for this one, we're on page, let's just make sure everybody's on the right page. I'm going to scroll down so you can see we're on page 4. Okay, so we're on page 4 for this video. And let me just ask y'all, what number divided by 3 would give you a -8? There's some number out there. If you divide it by 3, it would give you a -8. Now, I think most of you remember that a 24 divided by 3 would give you a +8. But we're trying to get a -1, so we need our j here to be a negative answer. So to prove it, we're just literally going to multiply both sides times 3. And that's a parentheses. I know that looks a little weird. And this is me showing parentheses for multiplication. If you don't like the parentheses for multiplication, you could actually, this is not recommended, but you could just show like, okay, I'm going to do a ×3 over here, which from elementary school, a lot of you have that little x. So then you could just say, okay, on this side, I'm going to do ×3. And in your calculator, you could just take the 8 that's negative, okay, and then just do times the denominator. And right there, it's going to give you that we should get a -24. So for this one here, we're going to get that j equals -24. Don't forget to put a negative. And we always want to check our work, and we already did just check it a second ago. We know that if we take a -24 in the calculator and then divide that by 3, we will get this -8. Okay? All right, so now for the next one. Some number out there divided by 6 gives me a 2.8. Now, I don't expect you guys to know that one off the top of your head. So for this one, we're just simply going to take the calculator and multiply our total by the denominator. So the math that we're about to do is just to simply multiply by the denominator. And you're going to see me in the language of algebra showing with parentheses that we're multiplying by 6. And when you do 6 divided by 6 over here, it cancels out. So that's just in the language of algebra. We're showing that the variable is now solved, n equals, and then we'll use our calculator, the 2.8 times 6, and we get a 16.8. So for this one, n equals 16.8. In this unit, you are in control of if you're right or wrong and being able to check. If we want to prove to see if 16.8 divided by 6 gives us this answer, we can just use the calculator. 16.8, that's what we think is the answer. We're going to plug it in. We're going to divide it by 6, and we do get the total that we're expecting, so we know we're good to go. And then here, if you see some number divided by -8 equals 7, you're just simply going to multiply that total by the denominator. So 7 times -8 is what we need to do in our calculators. And a lot of you might have the 7 times 8 memorized at 56, but if we make it -8, that's the -56. So here C equals -56. And to check, we just got to do a negative divided by a negative and make sure we get a positive answer. So again, we're just going to plug in the -56 over the -8. And when we divide that out, we do in fact get a +7 in the calculator. So we know we're good to go. We got a 56 that's negative, divided by our 8, that's negative, and we get our 7, we're all set. So to kind of formalize here, if you see a denominator under your variable, okay, this unit is all about recognizing what you see so then you know what to do. So if you see a denominator under your variable, here's what you do. You simply multiply the total by the denominator that you see under the variable. If you see a denominator of 3, you multiplied both sides by 3. When you see a denominator of 6, we multiplied both sides by 6. And when we see a denominator under our variable of negative 8, we just simply multiplied that total by that denominator. So make sure you take good notes here for what to do when you see certain things so you know what to do. We did cover that in our previous video. We talked about what to do if you see a constant. And I even reviewed up here, you simply do the opposite of whatever constant you see. So now we're over here, we just covered denominators. All right, now let's take a look at this t-shirt problem, okay? So you find a t-shirt that you really like, it fits, it's comfy, and it looks good. So you decide to buy 3 of these, and it's probably in different colors. And the shirt total is $68.97. So you buy 3 shirts, okay? I'm going to put an X for we don't know how much they cost. 3 times however much they cost would give us the total of $68.97. Now, you guys might not even be worried about this in the language of algebra. You're probably thinking, okay, if I've got those 3 shirts and they were $68.97 total, and I just want to know how much one of them cost, I'm just going to do that divided by 3 to see how much one of them cost. All right, cool, $22.99. And that's actually exactly what we're going to do over here. When you see now a coefficient to solve, you just simply divide both sides by that coefficient. Notice this time the 3 is a coefficient. It's the number in front of the x. And you guys learned how to identify that back on this page. Right here, you guys would tell me that that 4 was the coefficient of my variable f. So a coefficient is simply a number right in front of a letter. And if you ever see one of those, you're just going to divide both sides by that number. When you do 3 divided by 3 here, it cancels out. So in the language of algebra, we are proving what x has to equal. And on this side, you just do what we did in the calculator, 68.97 divided by 3, and we said that that was a 22.99. And that's how much each shirt must have cost. So what this kind of gears us up to understanding is that when we see a coefficient, we're going to divide both sides by that number, okay? Don't forget, up here what you saw was a denominator. And if you saw a denominator, we multiplied. But now if we see a coefficient, we're going to be dividing. So let's practice here. We've got 4 practice problems. So in this one, what I see with my variable, I don't see a constant and I don't see a denominator. I see a coefficient. And since that negative 5 is in front of my m, I'm actually going to divide both sides by negative 5. And in the language of algebra, we can use that fraction bar to show division. Anything divided by itself cancels out. So of course, we're proving what m has to equal. And on this side, if you don't know off the top of your head that a negative 15 divided by a negative 5 is 3, it's okay. You can just use your calculator. You got 15 that's negative, divided by the 5, make it negative, and you'll see right there that you get a 3. Now, of course, we always want to check. This unit is all about solving and then checking. So to check, we just simply do what we did in our previous unit. We just simplify. We think m is 3, so I'm going to plug it in. Negative 5 times 3. And when I simplify this, I do get a negative 15, and that's exactly what we wanted, so we know we're good to go. Now right below it, the only difference is really that this time my variable is on this side. So you can still use that strategy of dropping your line to kind of focus where your variable is. And again, notice we don't see a number by itself. I don't see a constant, so I don't need to add or subtract. I don't see a denominator, so I'm not multiplying. In fact, I see a coefficient, so I'm going to divide both sides by that coefficient. And you're just going to have to use the calculator for this one to see what y equals. You're just going to do 11, that's negative, divided by the 4. So we've got an 11, that is negative. We're going to divide it by the 4. And for this one, we're going to get a decimal, negative 2.75. You can leave it in decimal form. It doesn't say anything about making it a fraction. And friendly reminder that this year, getting decimals for your answer, that's fair game. All right, so over here, what do we see? we see a coefficient with our variable w. So if we see a coefficient, we divide both sides by that number. And again, we use the fraction bar to show the division. Over here, that's gone, and we have the variable all by itself. And now you can simply use your calculator to do 26 divided by 2.6, and we will get a 10. Now, if you're unsure, just simply plug it back in right here. You could just do 2.6 times W, so 2.6 times 10, and we should get the 26, and we do, so we're good to go. And one last problem here for practice. Let's talk about what we see. So we see 8.8 equals, and then it's not r plus 2, it's not r minus 2, so we don't have any constants. It's not r divided by 2, so we don't have a denominator. What this 2 is, y'all remember, that's a coefficient, so we're going to divide both sides by the coefficient. That's gone, the coefficient is gone, and we're now going to show what r equals. And most of you could probably see right off the top of your head that that's going to be a 4.4. And again, you can always use your calculator if you're unsure. And let's just check. Let's just make sure if I do 2 times 4.4 that I get the right thing. If I do 2 times 4.4, we should be all set. And we're good to go. All right, so now let's take our notes and make sure we can formalize what to do if we see a coefficient next to our variable. How do we solve? All we did, y'all, was we divided both sides by the coefficient. So you divide both sides by whatever that coefficient is. And now you might kind of see why we started out the unit, even back on page 1, when I walked you guys through how to identify all these different parts of the expressions. Because the idea is that if you see a constant, you're going to do one thing, and that's what we reviewed on this page. If you see a constant, you do one thing. If you see a denominator, you're going to do another thing. And if you see a coefficient, you do a third different thing. So it's all about what you see, and based on what you see, that's what you're then going to turn around and do. So we're actually now on the next page. We're on page 5. And now let's talk about this word reciprocal, because what you guys are going to start to see here are fractions. So that's kind of something new on this page when we talk about what we see. We're actually going to be looking at fractions on this page. But before we do anything with the fractions, I want to define the word reciprocal. Now, some of you might have heard it in elementary school, and you might have even had a teacher call it the refliprical, and I'll type that in here in quotations, refliprical, and that's just to kind of help you remember to flip the fraction. That's how some teachers in elementary school will teach that. So I've got a couple of examples right here, like if you have a 2/3, its reciprocal is a 3/2. I could start with the 3/2 and say its reciprocal is the 2/3, but all you're doing is flipping the fraction. Now in algebra, we have a fancy word called inverse, and inverse just means opposite. So if you flip the fraction, you've got its inverse or its opposite, which means you have its reciprocal. All right, so now let's talk about what to do if in an equation, when you've got your equal sign and you drop your line, now with your variable, you see a fraction as your coefficient. Let's talk about what to do here. First, my question is, what's the reciprocal of a 1/2? And you guys know the reciprocal of 1/2 would be a 2/1. So if you see a coefficient that's a fraction, all you have to do is multiply both sides by its reciprocal. And we're going to talk about why you do that in just a second, but go ahead and take your notes on just multiplying both sides by the reciprocal. Think about half of 2 over here. If you take half of 2, that's just 1. So that is canceling this out over here. And now the variable is all by itself, which again, that's just the language of algebra, learning how to show your work. And then we've got over here a -3 times 2/1. And if you're unsure of the -3 times 2, and 2/1 is just 2, you could use your calculator and get a -6. So in this problem, we're going to get that c equals -6. Now let's kind of just go back to the beginning and see as we check what this even said. It says if we take half of some number, we should get a -3. So half of -6 is my -3. And to prove that, I'm just going to kind of check that right here in green. I've got half of c, so half of -6. And this is me just plugging it in parentheses to show multiplication. And if you do half of a negative number, it's going to be a negative answer. and we do get a -3 like we were supposed to. So for the next one, we have a 3/5 of some number equals 6. 3/5 of some number equals 6. So since we see a fraction for our coefficient, we just care about the reciprocal, and the reciprocal in this case is a 5/3. So what we're going to do now is simply multiply both sides, and I'm just going to use parentheses this time to show that. I'm going to multiply by its reciprocal, which is again 5/3. Okay? So don't forget to show your work along the way with me and take notes. And right here, again, 5 divided by 5 cancels out, 3 divided by 3 is 1. All of this is just a 1 now, and 1 times anything is just itself. So in the language of algebra, we use the reciprocal to get the letter by itself. Now over here you have a couple of different options. In elementary school, your teachers would have taught you to put this over a 1 to make it a fraction. And now you've just got 6 times 5 is 30. And 1 times 3 is 3. So 30 divided by 3 would be 10. That's one way we can get our answer. Now, some of you could just go 6 divided by 3, which is 2. 6 divided by 3 is 2. And then 2 times the top part, 5, is 10. It doesn't matter to me. If you're using a calculator, here's what I would do. I would go ahead and get your 5/3. Go ahead and get that reciprocal in there. You've got 5/3. Now do times the 6. And you see we get the same answer. So you're multiplying this 6 by the reciprocal. We can double check over here. If I do -3 times the reciprocal of a half, which is 2, that's our answer. So if you see a fraction coefficient, here's how you solve. You multiply both sides by the reciprocal. Whatever the reciprocal is, you just multiply by that number. So here the reciprocal of 3/5 was 5/3. So I multiplied 6 by 5/3. In this example, my coefficient, that was a fraction, was a 1/2. Its reciprocal was a 2/1, so I multiplied both sides by 2/1. And some of you might be wondering now, if the denominator like this is a 1, can I just kind of forget about it? You sure can. So like if you saw 1/3 C, it's okay to say I'm just going to multiply both sides by that 3/1 or just 3. Okay, so we're going to see a couple of those examples here in a second. All right. So you see, like I was just mentioning, we've got lots of examples to kind of work through real quick. So let's talk again about what we see. We see an equation. Our variable is x. And this time the coefficient is a fraction of a 1/2. Friendly reminder that I could make this a decimal, and you guys could see a 0.5x equals 12. And if you saw that, whoops, let me make that a 12. You see a coefficient, so you would divide both sides by the coefficient. This is the same type of problem. And then you would just use your calculator. Let me get that pulled up again. And you would do the 12 divided by your coefficient 0.5, and we get a 24. So in purple, that is something we would have done in our previous video. You see a coefficient, you want to divide both sides by this. So there's the 24. So we talked about that previously in the video. Okay. Now here up above, we're seeing the fraction format of it. So instead of dividing, we simply just multiply both sides by the reciprocal. And what do you guys see right there? What's 12 times 2? It's the same answer. So the purple just kind of reviews one way you might see the problem. If you saw the 0.5 as a coefficient, that's what you'd do, and we'd get the answer. If you saw the 1/2 as the fraction coefficient, you simply multiply both sides by the reciprocal, and you see we get the exact same answer. Half of 24 is 12. Half of 24 is 12. And you can check it off to the side by just plugging in the half of the 24. And you guys know in your calculators, you'd literally make that a 0.5 and do 0.5 times 24. So let's make sure. 0.5 times 24 should be 12, and it is, so we're good to go. All right, so that is a 12. We are all set. All right, now right below it, see how all I've done is just moved this stuff to the other side of the equation? And let me just erase the purple to just give myself some space here now. All right, cool. So nothing really changes, y'all. I just put the variable on the other side over here, and it does have a coefficient, that's a fraction. So we're going to multiply both sides by a 4 over 1. And again, my parentheses, 4 over 1. I like to use parentheses at this point because I don't want to get confused with this x being a variable or a time sign. So 3 times 4 is 12 over 1, so that's just a 12. And we have solved for x. We simply multiplied both sides by the reciprocal. So what we're saying then, y'all, is that a fourth of 12 should be 3. Let's check. A fourth of 12. So a fourth is 0.25 times 112. We do get a 3, which is what we wanted right there. So we're all set. All right, let's kick it up a notch here. We've got 2/3 of some number is 6. So I see my fraction coefficient. I'm going to multiply both sides by its reciprocal, which is a 3/2. All right, so 3 over 3 is 1. 2 divided by 2 is 1. You could also think of 6 over 6 as 1. But again, all that stuff cancels out because 1 times x is just our x. Now, let's solve for it. 6 times 3 is 18. And that 18 divided by 2 would be a 9. You could do 6 divided by 2 is 3. And 3 times 3 is 9. Either way, we get a 9. Now let's check. 2/3. If we plug in 9, let's see if we get this 6. So the 2/3, I've got it in there. Now I'm going to do times my 9. And I get 6, which is what I wanted right here. So I know I'm good to go. 2/3 of 9 is 6. All right, back over here to one like this. And the reason I came back to one like this is because I wanted to remind you, if the reciprocal would be a 3 over 1, it's okay to just say, okay, I'm going to do times 3. You don't necessarily need to put the over 1, so you can just do times 3. So a third of 3 cancels out. A third of 3 is 1, so that's all gone. All right, 10 times 3 is 30. So we are done. Now let's check. Let's make sure that if we do a third of 30, do we get 10? And we sure will. Think about 30 divided by 3. That is 10. We're set. We're good. So this page right here is all about if you see a fraction, which is your coefficient to the variable. Remember, right in front of it, it's called a coefficient. All you do to solve is multiply by the reciprocal. So if you see a 1/5, all you got to do is multiply both sides by 5. And I'm just going to use parentheses again to show times 5. So 5 times this -4 is a -20. And again, let's say you forgot that. You could use your calculator. You had a 4 that was in there, make it negative. Times my 5, -20. All right, and over here that equals x. And to check, we'll do a fifth of -20. And let's review real quick for those of you who are just want to make sure you're getting this in the calculator. That 1/5 is your 0.2. And if you forget, you could just do 1/5. Okay, so you've got the 0.2. Now do times your 20 that's negative. And there's the -4, which is what we wanted right here. So we got the right total. All right, and now we have a final one here where our coefficient is a negative fraction, so a -3/4. So what we're going to do now is we're going to multiply both sides by a -4/3. A -4/3. Its reciprocal would be a -4 over 3. So we know this stuff cancels out and x is all alone. And now let's get that 4 over 3. Let's get that 4. Okay, so we've got a 4 that's -3. So see how I did that? I just did a -4 over 3. So I've got that in the calculator. Now I'm going to hit times my 16. Cool. So a negative 21.333, negative 21.3 repeating, and I'm just going to put the line over my decimal. And to check, I'm just going to literally leave that in the calculator, and then I'm going to do, so again, so let's not get lost in this. The negative 3/4, I'm just going to make it a negative 0.75. And I'm going to plug in my answer here, negative 21.3. And when I multiply these, I should get my 16. Now this should already be in my calculator, and it is. So now I'm going to just check by multiplying it by the, so times, oops, oh gosh, I messed that up, didn't I? Let me get that back in the calculator. So my 4/3 was negative, and then I did times my 16 to get my answer, and now I'm just trying to check that and making sure that if I do that times my 0.75 that's negative, I get a 16. We do. We're good to go. All right, so let's just kind of review all the different types of problems that we've seen so far. All right. Now, all four of these equations, to kind of just help us make sure we're doing the right thing here, all four of these will have the same answer. All right, so that should give you confidence that you're doing everything right if we get the same answer every time. Now, I'm just going to kind of take this one from the top and just talk about what do we see in this problem. I see an equation, and with my x, I see a coefficient. So I'm going to divide both sides by my coefficient. If you forget about that, it's on the previous page in our notes. So if I divide both sides by my coefficient, I'm going to divide 30 by 5, and 30 divided by 5 is 6. So here, 5 times 6 should be 30. So here we get x is 6. X equals 6. Now I think we can feel pretty good about that answer. And let's make sure then we get 6 for everything else. Again, 5 times 6 would be 30, so we know we're good. Now right below it, this is one of the ones where we see a coefficient that's a fraction. So for this one, we're going to multiply both sides by the reciprocal. Remember, it's all about what you see, and that's going to kind of dictate what you do. All right, so this is me multiplying both sides by my reciprocal. This stuff cancels out, and x is all alone over here. 4 times 3 is 12, and that 12 divided by 2 would be a 6. Another strategy I'm going to show you guys is you could take the 3/2 in red and get it in decimal form, and now just times that 4, and you still got your answer. So we're on to something here, just making sure we're doing everything right. We got the same answers so far. All right, now for this one. Let's go back to that previous video. When you see a double negative, you should catch right from the beginning that that's really a plus. If you're not subtracting 14, you must be adding 14. So now in this problem, let's kind of review again, what do we see? I see x plus 14, so 14 is now a constant. This is reviewing the video that you guys watched the other day. So you're going to subtract, you're going to do the opposite of whatever constant you see. We're going to subtract 14 on both sides. 14 minus 14 goes away, x is all alone. And 20 minus 14 right here, that would be my 6. So that one just reviewed what to do if you saw a double negative and what to do if you see a positive constant. All right, now this one, I see a 0.25. So this must be my decimal coefficient, so I can simply divide both sides by a 0.25. Anytime you have a number in front of the letter, you literally just divide both sides by that number. Now that's a 1.5. It might look like a 15 in your notes just because of the copier, but that's a 1.5. So I'm just going to do my 1.5 now. Whoops, not 1.8, 1.5. And we're going to divide it by the 0.25, and that is a 6. Okay. Now real quick off to the side, let me just review what would happen if you saw this 1/4 x. If it was a 1/4 of x, see now I'm making it the fraction format of the problem. But you guys know what to do in this situation. You know that if you see this 1/4 x, that you simply have to multiply both sides by its reciprocal, which is 4/1. And 4 over 1 is just 4, so it's okay to do that. And x here would be 1.5 times 4 is 6. It's going to be the same answer. And now I want to review then based on that. If you take a fourth of a number, that's the same thing as just doing x over 4, this purple problem. This purple problem is actually the same thing as this red and this blue one right here. Because if you guys were to see this problem here with a denominator, you guys know that anytime you have a denominator, you're supposed to just multiply both sides by the denominator. So these problems are all actually the same, and that's the reason why students get really confused in this unit, because they think that everything is a different problem. Sometimes it is. But here, if you have the decimal versus the fraction, they're the same thing, and taking a fourth of something is the same thing as dividing by 4. So in this unit, the trick is to get really good at what do I see to know then what do I do. If I see a denominator, I'll do this. If I see a fraction, I'll do this. If I see a coefficient, I'll do this. If I see a constant, I'll do this. Now I know this has been a long video. Stick with me. We're almost done here. Let's take a look right here. I want you guys to pause it. 3 of these equations below have an answer of 24. Only 3 of them. One of these right here does not have the answer of 24. So right now I want you to pause the video and I want you to confirm which 3 do have the answer of 24, and then I want you to circle the big one that would not have that answer, and when you hit play, I'll have the answer up here for you. Alright, so hopefully you made your way through all 4 of them, and I think that you'll see here, if you haven't already, that this is the one that does not equal 24. These 3 do equal 24. The work is there if you don't believe me or if you're unsure of how I got them. And the one that does not equal 24 is a 10. We have a reciprocal of 5/4. So 8 times 5 is 40, and 40 divided by 4 here would be a 10, so that's the one that does not belong. All right, let's make sure you guys are okay with the other ways of how to write problems like this. So if you see a fourth of x equals 5, what is another way to write that equation? It's the same as seeing x over 4 equals 5. Because think about it. What you would do here is simply multiply both sides by 4. And right here, the reciprocal is a 4. So for both of these, we get x equals 20. Taking a fourth of something is the same as dividing by 4. And for both of these, we're going to get that x equals 20. This is also a 1/4 as a decimal is the same as seeing 0.25 times x equals 5. And you would just use your calculator to divide both sides. And here, if you're not sure what 5 divided by 0.25 is, check it out. 5 divided by 0.25 is a 20, which is the same thing here. If we multiply 5 by the 4 over 1, that's a 20. And same thing here, if we do 5 times the 4, that's a 20. So for all of these, we get x equals 20. And I just wanted you to see, I'll kind of highlight it now to make it stand out, that here in green, you'll see a coefficient, that's a fraction. Here, you see a denominator. And here, you see a coefficient that is a decimal. All right, now let's take a look at this one. Again, just making sure there's lots of different ways you could see the same problem, which means you might have to do something different, but you still get the same answer. All right, so what's another way to write this equation? If you see x being divided by 2, that's the same thing, y'all, as seeing a 1/2. Taking half is the same thing as dividing it by 2. So this is the same problem. And a half could be written as a 0.5. So half of x equals -14. So all of these are going to have the same answer, even though they kind of look a little different. Let me just move these over. Boop, there we go. So again, if you see a denominator, you multiply both sides by whatever that denominator is. So for this one, we'd get a -28. All right, here, you'd multiply both sides by the reciprocal, but 2 over 1 is the same thing as just 2. So see, it's the same problem. You're multiplying both sides by 2. And here, you might remember from elementary school that dividing by a decimal If I divide by that decimal, think about it. If you divide by 0.5, you're dividing by 1/2. You might remember you're supposed to keep, change, flip when dividing by decimals. So there's the times 2 over 1. So it's literally all the same problem. It's the same thing, and we get x equals -28. So I know this might have been the longest video of all time, but you are done now. What you guys are going to do is you're going to just try these 4 problems on your own, and you're going to put the answers into a Google form, and that's just going to kind of let me know where you're at the end of this video. Thank you for watching, and don't forget to fill out your Google form.